Well, hello there. This is Venkat Subramaniam. You probably have seen me write code in what appears to be a terminal, press a key, and pops up the output. Developers have been asking me how I do it. So I want to show you exactly what the setup is and what is the different types of tools I use to make that happen. Let's get started. Well, of course, the first question is, why use an editor when you could be using an IDE? There are several wonderful IDEs out there, and I use a few of them as well. For example, IntelliJ IDEA or Visual Studio Code, and so on. IDEs are great when you have a lot of code to work with, a real project. And so when I do development and active coding, I do use IDEs. However, when I'm doing a presentation at a conference where I want to show a snippet of code, explain a certain concept, and show its behavior, or I'm working with a colleague or a student and I want to show quickly an example of something, I don't want to be messing with an IDE. Editors are really good for that purpose. Well, when it comes to editors, there are several of them available out there. You can choose whichever editor you like to use. In the past, you've seen my presentations years ago. I used to use TextMate, and I configured TextMate to do something similar to what I'm going to show you today. But off late, I've been using VI. That's right. VI is something I've been using for well over 30 years. Well, VI is one of the common editors available on a Unix-like system. Of course, the other one, which is also very popular, is Emacs. You can do similar things with almost any editor as long as you can figure out how to configure the editor to run some scripts. It's not just the VI that I use here. I also use a tool called QuickSilver to pop up the output as well. Let me illustrate those things in here. Let's first take a look at an example. You've probably seen them a dozen times if you've seen my presentations, but I'll run through a little example to illustrate what I'm talking about here. So here's a little Java code I have. All I'm going to do is simply say test over here, as you can see. I want to execute this code right there, and you can see the test pops out as the output. How in the world am I doing it? Well, that's what we're going to see. But just not that, for example. I want to write a little bit of a JavaScript code. Let's go ahead and say test over here again, and I'm going to execute that right there, and you can see the output pop up as well. And not just JavaScript. What if I want to write Python code, if you will? So I'm going to say hello in this Python code, execute it right there, and it pops up. So the question is, how am I actually doing all of that? Well, let's get to the plumbing and take a look at what's going on. Now, as I mentioned earlier, I'm using VI for this particular purpose. Now, VI allows you to do some macros behind the scenes. So for that, the first thing you need to do is to be able to use a file called .vimrc. Now, this vimrc, or depending on the version of VI you're using, typically resides in your home directory. I don't have a whole lot in here for this demo purpose, but I got two commands in here. Well, the first one I want to show you here is the slash. Well, when I hit the slash, it's going to perform R, as you would know if you're using VI. R is for replacing. So for example, if I am here, I can replace the H by typing R and maybe put a K in there. So the letter has been modified by K, and of course I'm going to undo that and show you again, and R and L, and you can see it replaces the letter with whatever I ask it to type. Well, that's exactly what I'm doing. So if I had a dash in here, if I enter the backslash, it does an R and then a tick. So it replaces whatever in that location with a tick. So there's no magic to it. So you can see I replace that with a tick and that with a tick as well. So essentially, that's exactly what I do with the slash. So I'm mapping the letter slash with the replace command to replace it. Similarly, I'm mapping a comma. So once I've saved the file, when I'm in the escape mode, I hit the comma and it executes the command that follows the comma. Just like when I hit the backslash, it executed the command R, and that it replaces the comma with the command : W. Well, the colon W is going to save the file. This is simply for hitting the carriage written or enter. Then it's going to execute the command run code.sh. And then, of course, it is simply executing that particular code, and the percent is passing to the run code.sh the file name that we are using. So in a sense, when I hit the comma, I'm saving the file, running the code run code.sh, and passing the file name as an argument to that particular file. Well, now that we saw what VI is doing, that's the end of VI's story. VI handed off your code to runcode.sh. Wonder what runcode.sh is going to do. So let's take a look at what runcode.sh is doing. This is going to be boring. Now, as you saw earlier, I ran Java code, JavaScript code, Python code. You could pretty much do any language you want with it. I typically use this for Haskell, Erlang, even C# and F# code, and so on. So how does the runcode.sh do? Like I said, runcode.sh is receiving the file name as an argument. So I clear the screen to begin with. That's why you see a little clearing happen in the beginning, so it doesn't show any of the output that VI is generating. Then I'm going to show if the $1, meaning the first argument given to run code, ends with a .java, then I'm going to run a runjava.sh and pass the file name to it. Similarly, if it's a .js file, I'm going to run runjs.sh. If it's Python, run runpython.sh, and so on. Once these commands execute, the last thing I'm going to do is to run what's called a qstooltip.sh. I'll talk about qstooltip.sh later on so you can see it. Well, what does the run java.sh actually do? Well, the run java.sh is interested in compiling the Java code and executing it. So in this case, you can see I remove the classes directory from temp, create the directory again, and then I'm finding the version of Java that I'm using. In my demos, I often switch between different versions of Java. I may show Java 8 to illustrate a certain example and show how that differs in another version of Java. So if it is a Java more recent version, or if it's an earlier version, I note down the version of Java. Once I figure out the version of Java, I'm just exporting that to a variable called version. Then I run the compiler, javac. I enable previews. I often use really recent versions of Java and use features that are not in final release yet. So I need to enable preview for that. And I also specify the version for the source, and I'm asking it to put all the binaries into the temp classes directory. That's the directory we created on the line number 2, and I compile the Java source code, and essentially in this case, I'm compiling all the Java source code in the current directory. And then I dump the output to the temp output directory. Well, then I ask, is the file .class existing for that particular file? Well, what if there was a compilation error? Then the file wouldn't exist. I can skip the part of executing the code. But if the compilation succeeded, I run Java, again enabling the preview, and I run the sample code in this case. I typically call the file as sample, but you can get a lot more smarter with it for different file names if you choose to, a little bit more scripting to write, that's all. Then I, of course, go ahead and execute the code, and I output the content of the execution, the standard output, into the output directory. And then once I'm output file rather, and that's it. That is running Java code. Well, how does it look like running, let's say, JavaScript code or running maybe a Python code as well? Well, JavaScript was a lot easier. I just run node, specify the file to execute, and put the output into the file called temp/output. Similarly, if you look at the Python, I'm running Python with the file name and asking it to put it to the output directory as well. Well, let's go back to the run code again. If you notice on the very end, I'm calling the qstooltip.sh. That's the last part of the puzzle. I want to show you what it does. So let's take a look at the qstooltip.sh. What does that do? Well, it's an Apple script file that's going to really execute the QuickSilver. Well, there are several tools available on the Mac. These are useful launcher applications. And for example, Alfred is one of them. QuickSilver is one of them. They're all very old tools, but they work like a charm. So I use QuickSilver in this particular case. And in addition to launching applications, QuickSilver also allows you to perform a tooltip, which is really nice. For example, if I bring up QuickSilver here, I'm going to simply say hello there, and I say large text, and I can hit the return. It says hello there. That's exactly what I do, except rather than me manually running this, I am automating the execution of QuickSilver to perform a tooltip. So how do I do that? Well, here is the command for it. I'm running Apple script right there. When that qstooltip.sh is executed, I set the file I'm interested in using, which is the temp output is the file. Then I tell applications, that is literally a Apple script command. So tell application QuickSilver to show large type the file content as text. So in other words, I read the content of the temp output, which is, remember, the file into which we dump the output of executing your code, and then that's stored in the variable called set file content, and then I'm displaying the file content as a text as a large type using QuickSilver. Well, that's pretty much it. And once you set that up, as you can see, I can take pretty much any code in any language as long as I can configure it and simply execute it and do whatever I want to do in quick demos. And I hope you found that really useful. Thank you. That's all I have in this presentation. Create your own scripts, enjoy and configure things, and do amazing short demos. Cheers.